Let's be honest, Web3 onboarding is basically broken. Imagine it like this way. You're a developer who's just built an incredible decentralized application. You're excited to share it with everyone. But then reality hits. Your users, even the tech-savvy ones, face a gauntlet of friction that would make the most determined personal question whether is it worth it? First, they will need to install a browser extension such as MetaMask. Then comes the intimidating part, which, write down a 12-word secret phrase with stern warnings then that losing it means losing everything forever. Next, they need to, somehow acquire the cryptocurrency just to, interact with your application, which means navigating exchanges, KYC processes, and fees they don't understand. And if they even make a wrong click, send funds to the wrong network, or forget the seed phrase, the game is totally over. Okay, no customer support is there, no forgot password button to click. This isn't just, bad user experience. It's basically a brick of walls that stops 90% of the users to upping into the crypto world. We have built this amazing decentralized future, but we have locked it behind a door that requires a computer science degree with a high pain and tolerance to open. But here's the thing which can, solve it. It doesn't have to be this way. What if I told you, you could onboard a complete Web3 newcomer who's never heard of MetaMask, never, seen a seed phrase, and doesn't even, own a single Satoshi, and have them minting their first NFT on a Bitcoin secure network in under 60 seconds. No extensions, no seed phrases, no crypto needed, no, fancy jargons. Just an email address or, even Google sign-ins. That pretty much sounds impossible, right? That's exactly what we are building today. Welcome to the future of Web3 onboarding, where we are, combining the Privy's revolutionary embedded wallet technology with Bitcoin's secured blockchain in order to create the experience that feels like Web2, but, gives you all the power of Web3. Like fantasy, right? No, it's real. By the end of this tutorial, you'll have the ticket to Web3, a production-ready application that basically proves seamless blockchain onboarding isn't just possible. It's actually straightforward to implement. Now, before we deep dive into the code, let's just talk about why actually are we building this on the rootstock specifically? Because this choice is absolutely critical in order to understand the power of what we are actually creating. Rootstock is what we call a Bitcoin layer 2, or more technically, a sidechain that's merged mined with Bitcoin. What does that mean in practice? It means Rootstock inherits the security of Bitcoin network. Everyone in the world has heard about Bitcoin. So Bitcoin is basically the most secure blockchain on this planet, and it's well tested. The rootstock, while simultaneously being fully compatible with Ethereum virtual machine, think about that for a moment. You are getting the Bitcoin security, that network that's been running without a single hour of downtime since 2009, secured by millions of mining machines across the globe, combined with the ability to use all your familiar EVM development tools, Solidity smart contracts, and existing libraries like Ethers, Web3 or VM. This is, specifically a game changer for developers. You don't need to learn a new programming language. You don't need to rebuild your entire tech stack. Your React components work exactly the same. Your smart contracts deploy the same way. Your Web3 libraries connect identically. But instead of deploying to a standalone chain, you're deploying to infrastructure that's basically secured by Bitcoin's proof of work, which currently represents more computational power than anything else on this planet. And here's where it gets even better. Rootstock offers significantly lower transaction fees compared to Ethereum mainnet, making it economically viable to onboard users at a high scale. When you're minting NFTs for potentially thousands of attendees, those gas fees matters. Okay, on Rootstock you can provide an experience without breaking the bank. So when we combine Rootstock security and low fees with Privy's seamless authentication, we are not just building a better UX, but we are building a bridge that can actually bring mainstream users onto Bitcoin ecosystem without them needing to understand any of the underlying complexity and jargons. That's the promise we are delivering today. Let's talk about Privy and why it exists. But to truly understand Privy, we first need to understand the problem it's solving, what I call the crypto chasm. Imagine you have built a revolutionary decentralized ticketing platform. No scappers, transparent pricing, verifiable authenticity, everything NFT ticketing platform promises. You launch your platform and people are genuinely excited. They arrive at your website ready to buy, but then they hit the wallet connection screen. Suddenly, 90% of your potential users are gone. They are just vanished. They have, closed the tab and gone back to the Ticketmaster despite all of these problems because at least they know how to use it. This is a crypto chasm. the enormous gap between Web2 experience and Web3 experience. On one side, you have users who are accustomed to, clicking sign in with Google, getting an email verification code, and following up this process and running 30 seconds. On the other side, you have blockchain applications that require users to manage cryptographical keys, take responsibility for financial security, and would make a bank compiler officer nervous. That would basically make a bank compiles officer nervous sometimes. The traditional Web3 stack essentially tells user, welcome to user application, please first become master's bank. Here's your cryptographical key, don't lose it, don't share it, and understand there's no password reset if you forgot it. And you'll need acquire cryptocurrency from an exchange, first of all, which requires KYC verification, bank transfers, and understanding the difference between layer 1 chain, layer 2 chain, and even layer 3 chains. Can you imagine if Gmail required you to, set up your own email server before sending your message first? Or if Netflix required you to understand the video codecs and content delivery networks before watching a show? That's essentially what we are doing in Web3, and no wonder why the adoption is so slow. It exists to bridge this chasm. It's not just another wallet, it's basically a complete authentication and key management infrastructure which is designed in order to, ground up, give users a Web2 style experience while developers with a standard Web3 interfaces. When a user logs in with Privy, they are They are not connecting a wallet in the traditional sense. They're authenticating with an identity provider they already trust: their email, their Twitter handle, their Google account, their Apple ID, and Privy on the backend handle all the blockchain complexities by itself behind all of the scenes. Here's what makes it profound. The user never sees a seed phrase, they never manually manage private keys, they never worry about which network they're on or whether they have gas fees. They just log in, they would, with any modern web application. This is a crucial part. They actually look at a real wallet with real cryptographic keys capable of signing real blockchain transactions. The security is there, the decentralization is there, the self-custody can be there when they are ready for it, but the friction isn't there on day one. Privy has effectively solved a problem that the crypto industry has been, struggling with for a decade. How do you give users the sovereignty and power of blockchain technology without making them feel like they need a PhD or something to use it? The answer isn't dumbing down the technology or compromising on security. It's abstracting away all the complexities without compromising on the functionality. It's meeting users where they are, with interfaces they understand and gradually introducing them to the power of Web3 as they become more comfortable. This is particularly powerful for, use cases like event ticketing, loyalty platform, community memberships, or any application where your primary goal is to deliver value through the blockchain technology, but not to, teach people about the blockchain. Your users want a ticket, they want access to your event, they want proof they were there. They don't want a lecture on elliptic curved cryptography on the benefits of non-custodial wallets, at least not on their first interaction. Privy basically provides you with the tools to onboard these users and educate them within the first second, get them to the blockchain technology, benefiting from it. Okay, seeing its value in their lives, and then when they're ready, they are curious, they can yourself introduce them to deeper concepts of the blockchain, like they can export the wallet from Privy, they can integrate it with MetaMask, they can do multi-chain bridging, or even migrating to full self-custody. But you don't get their first experience behind these concepts. Let's pull back the curtain and look at how actually Privy works under the hood, because understanding this architecture is crucial for building secure production-ready applications. And I promise, this is where things will get really, really interesting. From a technical perspective, at the core of Privy's technology is something called an embedded wallet. This is not a browser extension that users download. It's not a mobile app they install. It's a wallet that exists within the context of the application itself. It directly into your React, Next, Angular, Vue, or any other app, your website, your D app. When a user logs into your application, your Privy, an Ethereum compatible wallet is automatically created for them on the back, associated with the identity and made available to your application through the standard Web3 interfaces. But here's we need to address the elephant in the room. If Privy is creating and managing the wallet for users, doesn't that mean Privy has access to users' private keys? Isn't that just another form of custodial wallet, defeating the entire purpose of blockchain self-custody promise? This is the brilliant part, and it's where we need to talk about multi-party computation, or MPC for short. MPC is a cryptographic technique that allows multi-parties to jointly compute a function over their inputs while keeping those input private. In Privy's implementation, when a wallet is created for a user, the private key is never actually generated as a single piece of data that exists in a single place. Instead, it is splitted among multiple pieces using a mathematical process that ensures that no single share of the key on its own can be used to, reconstruct the whole private key or to sign the transactions. Let me break this down with a simplified semantic model. Imagine a private key is a secret message. A traditional wallet security is like, writing that message on a piece of paper and keeping it in a safe place. If someone breaks into your safe, they have your message. With MPC, it's more like, taking message, running it through sophisticated mathematical process and splits it into three encrypted pieces and giving one piece to user's device, one piece to Privy secure infrastructure, and one piece to backup recovery system. Here's the magic. You need at least two pieces of those three pieces to reconstruct the whole private key and, sign a transaction. What does this mean in practice? When a user needs to sign the transaction, say to mint the NFT ticket in our platform, the device holds one key share. Privy's server holds another, and they come together cryptographically to produce a valid signature without ever reconstructing to the full private key in any single location. It's happening in microseconds, transparently, without even the user knowing anything, and is different from clicking confirm transaction in MetaMask. But the real genius is in the security model of this enables. Privy never has unilateral control of the user's fund. Even if Privy's server were completely compromised, hacked, seized, or shut it down, an attacker still couldn't access your funds because they'd only have one share of the key. Similarly, if a user's device is compromised, the attacker still can't steal funds because, again, they only have one share. You need both shares in order to create a valid signature, which means you need both the user's authenticated session and Privy's cooperation. This also solves the recovery problem elegantly. Remember how losing your seed phrase in traditional Web3 means, permanent loss of funds. With Privy's embedded wallets, recovery is, basically tied to the user's identity provider. If they lose their device, they simply log in again with the Google account or email authentication or Twitter, and they're back in the business. The third key share, the backup recovery share, can be used along with Privy server share to reestablish the whole access. The user experience feels like, recovering any Web2 account, but the cryptographic security is actually stronger than, many people seed phrase security. Because let's be honest, most users write their seed phrase on post-it notes or screenshot them. Now, here's some important part for you as a developer. You don't need to implement any of these complexities from your application perspective. Privy's embedded wallet exposes itself as a standard Ethereum provider. The exact same interface that MetaMask uses, Coinbase wallet uses, that Wallet Connect uses. You interact with it using the same ethers.js VM code you had used with any other wallet. You call provider.getSigner, you sign transactions, you send them to the blockchain, the abstraction is complete. This is powerful because it means your application can support both embedded wallets such as Privy and traditional wallets like MetaMask, Wallet Connect, and simultaneously using the same code paths. Users who already have MetaMask can connect with that. Users who don't can use Privy seamless onboarding. You are not locked into one paradigm or other. You are offering choice while maintaining a consistent developer experience. That is the biggest issue that we are solving here. One more critical architectural point: because Privy uses OAuth style authentication flows, all of the security infrastructure around identity verification, email verification, or token management, session handling, rate limiting is handled by Privy infrastructure itself and the identity providers themselves. Google security team, Apple security teams, email provider security, you're leveraging all of the industry-grade security that has billions of dollars of investments behind it. You're not rolling your own authentication system and hoping to get the best security out of it. We are standing on the shoulders of giants. The result of the system that's actually more secure for the average user than the traditional write down your seed phrase approach, while being dramatically more usable. And for developers, it's clean as you get that basically integrates into React in an afternoon. That's a part of good abstraction. So we have established that Privy solves the onboarding problem, and we have established that Rootstock offers Bitcoin security with EVM compatibility. But you might be wondering, why are we bringing these two technologies together specifically? What makes this combination more than just sum of its parts? Let me paint you a picture of what we are actually enabling here. Rootstock represents something unique in the blockchain ecosystem. It's not another Ethereum competitor trying to be fast or cheaper by making different security trade-offs. It's not a new layer one with its own consensus mechanism that may or may not stand in the test of time. Rootstock is instead directly securing its state through merge mining with Bitcoin, meaning the same miners who merge the Bitcoin are simultaneously securing the Rootstock with no additional energy expenditure or separate security budget. What this means is when you're building on Rootstock, you're building on top of the most decentralized, most secure, most sensor resistant, and most test most battle-tested blockchain in the planet, that is the Bitcoin. It isn't going anywhere. It has the network effect, the hash power, the regulatory, the clarity, and the institutional adoption. It's basically the bedrock of cryptocurrency, and Rootstock gives you programmability on that bedrock. But here's where, Privy connection becomes very crucial. Bitcoin has historically had a marketing problem, or perhaps more accurately, an accessibility problem. It's not typically seen as, something you use for applications for DeFi, NFTs, for those kinds of interactive experience that have made Ethereum and other smart contracts platform exciting. There's a perception that, Bitcoin is for serious investors and crypto natives, not everyday users experimenting with the new applications. This perception is technically wrong. Thanks to Rootstock, you can absolutely build sophisticated dApps on Bitcoin infrastructure, but perception matters. And more importantly, even if you build the most amazing application on Rootstock, you're still facing that same onboarding chasm we talked about earlier. You are still asking users to, configure their MetaMask, configure it for the, Rootstock network, acquire RBTC somehow, and understand gas fees denominated in a cryptocurrency that they even don't own yet. This is, we enable the Privy, which will become the transformative for the Rootstock ecosystem specifically. By integrating Privy into Rootstock applications, we are essentially creating an express lane onto Bitcoin's infrastructure. We are, taking all of Rootstock technical advantages, the security, the low fees, the EVM compatibility, and the Bitcoin alignment, and we are unwrapping them in an experience that feels like creating an account on any modern web application. Think about the user journey we are enabling. Someone sees your Rootstock DApp, maybe it's our Ticket to Web3 example, maybe it's a DeFi application, maybe it's a gaming NFT marketplace. They click sign in. They use email or Google account or Twitter. Within seconds, they have a wallet on a Bitcoin secured blockchain. They can immediately interact with the key. They are now part of the Bitcoin ecosystem. That NFT they just minted, it exists on the infrastructure secured by Bitcoin mining. The transaction they are making, they are on chain that enhanced Bitcoin security model. You essentially onboarded them to Bitcoin without ever, mentioning the private keys, without seed phrases, without, making them buy BTC on an exchange, without overwhelming them with technical jargons. And as they become more familiar, gradually they understand the technology and the blockchain jargons behind that. In general, they are well positioned to explore deeper, maybe, bridging assets between Bitcoin and Rootstock, maybe exploring other Bitcoin L2 solutions, maybe eventually understanding and appreciating the significance of the security model they have been benefiting from all along. But when we, built the Ticket to Web3 using Privy and Rootstock, we are actually creating a proof of concept that basically demonstrates this entire thesis in compact. Understandable examples, someone arrives at our site with, zero crypto knowledge. In under 60 seconds, they have authenticated, received a wallet on a Bitcoin secured network, and minted their first NFT, all without ever feeling that, they have left the familiar territory of normal web applications. That's the future we are building toward. And the technical foundation we are establishing in this tutorial is, how you make the future real for your own applications. All right, guys. So as you can see here, we are headed towards our laptop screen. All we need to do is, first of all, we need to, build our smart contract. So in order to make our smart contract, we will head over to remix.ethereum.org. A remix is basically an online IDE through which we can easily, deploy and, integrate the smart contracts on any EVM stack chain. So we'll create a blank workspace with us get to Web3. So yeah, here as you can see, we have got a blank project, a blank workspace basically. Now we can create a new file here, name it as event tickets nft.sol, and in here I'll just chip in the code of smart contract that we are going to use in this tutorial. So let me just quickly go over the code of the smart contract and briefly explain it to you guys so that you guys can be in the loop. So as you can see here, first of all, in Solidity we need to express the license that we are using. In this case, we are using the MIT as stated here, the MIT. After that, we are specifying the version of Solidity that we are using. In this case, we are using the version upper than Anchor to 0.8.20. After that, we have a couple of import statements as we are minting the ERC720 token. First of all, we are importing the Open Zeppelin contract of ERC721, followed by the ERC721 enumerable.sol right from the Open Zeppelin itself. And lastly, we are importing the ownable variable for security of the owning of the NFT. Alright, so after all of the imports, we are basically declaring our contract. In Solidity, we use contract keyword in order to declare the contract, followed by the contract name as event ticket NFT, and then we are specifying that this contract extends the functionality of ERC721 ERC. Alright, so after that, we have unsigned integer private variable of token IDs for the NFT token ID, followed by the string data type of base token URI. That's basically the link to the image. And thereafter we are specifying a mapping of unsigned integer to unsigned integer. That's basically the timestamp of the minting. After that we are just specifying the event that ticket is minted and specifying the parameters such as attendee address, token ID, and timestamp. Thereafter, we are defining a constructor which will give the ERC721 basically the name and the token symbol, followed by the parameter to enable, that will be the message.sender, the deployer of the contract. Thereafter, we will set the base token URI to something of IPFS hash for now, because this is a tutorial and we need to keep things simple. Thereafter, we have our main function, that is the mint ticket function. Here we are requiring the attendee address, and in return we are giving out an unsigned integer. So first of all, we are checking that address is not null, and if it is null, we are just throwing the log that it cannot be null and reverting back the function. Thereafter, we are pushing the token ID, basically incrementing it using the plus plus method. After that, we are assigning an unsigned integer new ticket ID and setting it to the token IDs. Thereafter, we are calling the save mint operation and giving out parameter of attendee and new ticket ID. After that, we are, basically setting the ticket main timestamp mapping to the block.timestamp. And lastly, we are just, emitting the event which we created earlier and returning the new ticket ID. So yeah, this is the mint function, and through it, our NFT will be successfully minted. Thereafter, we have few more additional functions, I would say, such as set base URI. If we want to change the base URI of the NFT, we can set it here. Thereafter, we have the base URI function, which basically is a view function which, you know, basically reads the URI that is currently set. Thereafter, we have the total minted function, which basically returns the token IDs. And we have a few more functions such as update, which is again an internal function, and that overrides the ERC721 and 721 enumerable libraries. And it basically returns an address of the NFT data. Thereafter, we have the increase balance and supports interface function. These are basically the additional functions, but the main functions we are going to use in this tutorial is the mint ticket function. So let's just compile this smart contract by using command S, or you can go to the compiler tab. And once it's successfully compiled, we can go to the deploy tab, and here we can choose our wallet from the browser extension as MetaMask. Now if you have got the TRBTC tokens in your MetaMask, as I have already got them, you can continue. If not, we need to head over to faucet, and as you can see, we can just paste our address in here. Just copy the address, and let's say I'm not a robot, it can be possible though. Then I'll just hit get free TRBTCs. Okay, it usually takes 30 seconds in order to send the TRBTCs. We just need to wait, and we'll get the RBTCs. So yeah, we can continue from there. Okay, now we just need to hit the deploy button right here. So I'll just hit confirm. Let me just see it in my MetaMask. We can also open this up in our block explorer. Alright, so as you guys can see, our contract is successfully deployed. We can see the status, it is success indeed, and our faucet has also been sent right here. So I'll just head over to remix, and as you can see here also, we can see our contract and our deployed contract addresses. We can test out the functions from right here in this tab, and we can copy the contract address from right here. So that's how we deploy the contract, and that's what we need to do with the smart contract at this time. Now we need to move one step further, and in order to make a settle and secured event ticket NFT platform, we need to make a front end with Next.js and Privy itself. So now in order to create our front end, I'll just open up the terminal, and in here we will make a we host it. And right here we will make the directory, name it as ticket to web3. We will cd into this directory, that is ticket to web3. And right here we need to create an instance of Next.js project. So we'll do that. We'll do npx create next latest slash, so it will just install the create next latest. All right, so we need to provide a custom name for it. So we'll say yes, use the default. All right, guys, so Next.js repository is successfully created. We can just see it into our folder. And now we will, install a Privy and Ethos library in it in order to, obtain the functionality of these libraries. Until then, till the libraries install, we can, just go into and switch on new terminal tab. In here, we can basically call the cursor to show up so that, we can start coding real things. Now, this is basically the Next.js format. We have our app folder right here. We have node modules and public folder and some configuration files. So first of all, what we are going to do is we are going to create a config folder, and in here I'll create a privy.ts file. This is where we store the configuration of our privy. Let me just first of all chip in some code so that we can go through it. So this is gonna be our configuration. All right, so this is basically our configuration files in which we have stated the Rootstock testnet configuration and the contract address, the Privy app ID, and contract ABI. First of all, what we need right here is we need the contract address and the Privy. Right here we have our remix of event ticket, and we can basically copy the address from here and head back to the cursor and paste our contact address followed by the Privy app ID. In order to secure a Privy app ID, we need to open a new tab, and in this we will go over to privy.io. This is basically the homepage, the dashboard for Privy. Now we'll just log in, and as you see, I have my free plan. I can basically the new app. Right here, let us name it Ticket to Web3, and let's create this app. Select the platform as web, and as we are using the app in our front end, we are not proposing any server-side backend task. So we are going to use the app ID in this case. So we'll just copy this app ID and close this and head back to our cursor, and we will, paste this Privy app ID right here. After that, we to contact ABI, the functions which we want to interact with in the contract. That's what our privy.ts file does for now. After that, in order to, secure and interact with the smart contracts, we would need a utils file, which basically, calls a function for the smart contract. So just go ahead and make a new directory, utils, and right here, we will define contract, or for simplicity, can rename to contract.js. And right here, we will, define some code in order to, establish a connection with the contract. First of all, we have the mint NFT function, and that's the main function we are going to use in this tutorial in order to basically mint the NFT. We are importing the ethers and contract address and contract ABI from our config file. Thereafter, we have this mint NFT function that basically takes the provider signer and thereafter establishes a connection with contract using ethos.contract by providing the assets of provider signer and contract address. Thereafter, we are using the user address and sign a transaction of contract address, and signing the receipt of it. In return, we are giving out the transaction hash and token ID to output it. And thereafter, we have one more function that is get explorer URL. That is a basic function in order to see the transaction hash on the Rootstock Explorer testnet right away. So yeah, that's what it's gonna be in our utils/content.js file. Now we would have to make some components which will be Privy-based components which we can later wrap it to our layout file so that our whole app consists the secure native wrapping of whole Privy providers around it. So make a new directory and name it as components. In here we will make Privy providers dot js6, and we will chip in the code, and we can collect its name as Privy provider wrapper dot jsx. Now we are doing here is first of all we are getting the Privy provider from the official React auth, and thereafter getting the configuration informations. And lastly, we are just, making a wrapper to, go around our app and, defining the properties in the Privy provider. First of all, configuring the app ID. Thereafter, the appearance, we are, setting it to light theme. If you want, we can also have it to dark theme. We can have the accent color and we can have the logo, the options to sign in with. We can also set something like Twitter, Twitch, TikTok, etc. We have multiple options. We have, embedded wallet options if you want to, require user password on create set to true or false. And later on, we have the default chain, which we have set to Rootstock testnet, of course, and the supported chains also to the Rootstock testnet. After we are just, wrapping the provider into the children component. So we will, make one more component as, minting section .jsx. This will function in order to interact with the smart contract that we have deployed. So first of all, what it does, it basically imports the user state, user wallet hook. Later on, it gets the contact information functions, that is the mint NFT and get explorer URL. And right here, we are defining the minting section. First of all, we are getting the state of wallets from the use wallets and defining several user state variables of is minting, minted token ID, error, transaction hash. Thereafter, we are getting the handle mint function that handles the minting process. First of all, if wallets are there, it goes through. If there aren't, it sets error that there are no wallets found. After that, we are using the try statement and checking the embedded wallet and getting the results and awaiting with it, mint NFT function, putting the variable configuration into it. So yeah, that's what I'm doing. And now we will, create another component which will be authenticated section.csx. Now this section is, basically for checking whether the user is authenticated or not. Just displays the email and wallet address, and we can even use the Twitter username of the user. And thereafter, we can basically display the email, wallet address, and give out the buttons for sign up, sign it to the user. That's straightforward, right? To handle the layout page also. In this, we need to wrap the whole body around the provider. So we'll do that, and right here we will define type, and we are good to go. We just need to wrap this Privy provider wrapper into the children component. Very last, we will, handle the page.tsx file. It is right now set to, Voso's basic frontend. We will change it, and right here we'll define our own frontend. First of all, we'll import the use Privy hook, login section, and authenticated section, which we declared earlier. Thereafter, we'll initiate the home. First of all, we'll do it. We will import the ready authenticated user login allowed from the use Privy hook itself. Thereafter, we'll see if the user is ready, and if it is, it will show that it is loading the ticket to Web3. If it's not, it will return all of the information of ticket to Web3, proof of attendance, NFT on blockchain, and it is powered by Rootstock. And if it is not authenticated, it will basically show the login section, authenticated section. Lastly, we have a basic photo. So yeah, that's all we need to open the app in order to sustain and get the output of the tree. So let's just save everything fastly. And all right, so one of the last things is we forgot was we did explicitly define the styles. So we just need to go to global.css and put those styles right there. As you can see, here we are on our application to get to Web3, and our front end is pretty straightforward and stylish. So let me just go ahead, and in here I'll say sign in to claim ticket, and here I can enter in my email. For this case, I will use rhythmnagrani@gmail.com. I'll just submit the email, and I'll just wait for the confirmation code. All right, guys. So we have successfully logged in, and now if we don't have the Rootstock wallet, we can basically create new wallet right here. It will be connected to our Privy account. So I'll just create it. So yeah, it's created. Now what we can do is we can just copy this address because we would need the initial TRBTCs with the rootstock faucet for it in order to interact with the blockchain and perform the NFT claim. We need some gas, right? So yeah, if I try now, it will fail because we don't have TRBTC. So I'll go to the faucet, right? Here in the faucet, we will paste the address and I'll say I'm not robot. because it is what it is. And this faucet takes approximately around 30 seconds to deliver our PRBDC's tokens. Once it's done, you can come here and press the claim NFT ticket button. Now it will ask me to approve the transaction, and I'll just hit approve. And we'll just wait for the transaction to be processed on top of the Rootstock testnet via the public node that we referred in the code. It basically takes around 30 seconds. And as you can see, we can also hover to a contract right from here on which contract we are interacting with. And as you can see, our transaction has gone through and we have successfully claimed our NFT. And this is the transaction details from two estimated fees and the fees. Okay, so we are all done with the D app. We have successfully created a whole tab which basically performs event ticket minting by its own using one of the best softwares that's free. You can also check out the blockchain explorer and check out the events and internal transactions in our contact. And yeah, that's what we built today. And that's it. We just onboarded a complete beginner onto Bitcoin's network in under a minute. No MetaMask, no seed phrases, just an email with 2 clicks. This is gonna be the future of Web3. Actual technology works so smoothly that users don't even realize they are even using a blockchain. So guys, check the description for the code. I will provide the GitHub link, Rootstock docs, and Privy docs. Now just go and build something crazy and amazing that actually gets used.